Hi there. So you'll notice the videos look a little bit different, and I'm just using a different way of recording them. And the nice thing about it that I like is that it's using the same PDF as your guided notes are coming from. And so if you're using those, if you're printing those off or using them to follow along, it's going to line up a lot better. If you would be really interested in having printed copies and you don't have access to a printer at home, reach out, let me know, and I'm happy to see if we can find a way to make this work. So we're going to get started today talking about finding limits as x approaches infinity. So this is going to be really similar to other limit problems, except for instead of approaching a number here, we're going to talk about what it means if x is approaching positive or negative infinity, and your homework is coming from 2.6 today. So this is easier, I think, to think about if we start back thinking about graphs and the definitions of limits. So if we think about what the limit is as x approaches infinity, the question just becomes, what is the graph doing at that point? And in this case, it's as x is getting bigger and bigger and bigger. If I'm looking at this graph here, x getting bigger and bigger and bigger is happening here, right? This is going towards infinity. So for the graph, I'm looking at just this part here as it keeps going. I can see that this graph is pointing upward, so it's going to keep going towards infinity this direction. So if I'm looking at this example here, that means the limit as it goes towards positive infinity is going to equal infinity. Now, this is usually going to be the case. Usually, as we look at graphs, they either keep going in one direction up, or maybe they keep going in one direction down. Now, it's also possible, if we look at negative infinity, that we have something like this, which, if you remember correctly, is a horizontal asymptote. If I look towards the other arrow, as it goes towards negative infinity down here, we can see that this is flattening out. So here we have a horizontal asymptote at 0, and just because it's different on one side doesn't mean that it's not still the limit here. So on the limit as x approaches negative infinity of this function, f of x, is equal to 0. Now another type question would be something like, all right, can we graph a function where the limit as x approaches positive infinity equals 0 and as it approaches negative infinity equals 3. Now, we have two numbers. It's not equal to positive or negative infinity, so that means that we have horizontal asymptotes. And I say plural because these are two different numbers. If they were both 0 or both 3, I would define that as one horizontal asymptote. So we'll have two, one at 0 and one at 3, which are the numbers that we see here. So if I start looking at my graph, the first thing I'm going to do is I'm going to draw in my asymptotes. And I'm going to draw one in, nice little dotted line at 0, and another one in at 3. And this is just going to help me keep organized. If I want to go label things, 1, 2, 3 right there, and we have our asymptotes. Now, the one at 0 is going to be for positive infinity. So here we have positive infinity here, which means that we're going to use the asymptote 0, and the negative infinity is going to be using the asymptote at 3. Now, our curves can do anything in the middle. We don't know anything about the limits at any sort of defined numbers. We just know what's going to happen at the ends here. So maybe this one's going to approach like this, and then maybe we have something like that. That would be a lovely behavior there. And on the other side, again, we don't know what's happening over here. We can draw whatever we want. I'm going to say, okay, well, it's going to have a discontinuity, and draw just a dot here, and then draw another horizontal asymptote going that way. This, again, you can draw whatever you want in here. You should have approaching the asymptote at 3 with the negative side and at 0 with the positive side. Now, what I'd like you to recall from previous class, specifically pre-calc, is that rational functions like these have horizontal asymptotes most of the time. Hopefully, at least with a little bit of a memory jog right now, how to find these. So the first step of finding your horizontal asymptote is to drop all but the highest degree term from the numerator and denominator. So what you want to end up with is just one term in the numerator and one in the denominator. Now, before we get started, always make sure that you're actually approaching infinity, because horizontal asymptotes only affect positive and negative infinity. So in this case, the highest degree in the numerator is 5x to the third, so we'll just cancel out, drop that. And in the lowest the highest degree term in the denominator is x squared. Remember, degree is the same as exponent. So we want to simplify what's left. So in this case, we have limit as x approaches infinity of 5x to the third over 3x squared, which is the same as the limit as x approaches infinity of 5x over 3, because I simplified the x, cancel out, and we end up with 5x over 3. Now, there are 3 conclusions that we can draw from this simplification. First one is where we still have x terms in the denominator. So we have some k over x to the n. We might end up with just a number because the x terms all cancel out, or we might end up with some multiple of x to the n. In other words, we have x left in the numerator. Now, each of these, you draw a separate conclusion. If x is in the denominator, that means the limit as x approaches positive or negative infinity is going to equal 0. If it's just left as a number, the limit as it approaches positive or negative infinity is that number. And finally, if it's a multiple of x, that means that the limit as x approaches positive and negative infinity is infinity. And hopefully this should make sense here. If we're dividing by a really big number in the denominator, that means we're going to get close to 0. Here, x isn't being affected at all because it's not there anymore. It all canceled out. And multiplying by infinity is going to give us infinity. So it's one of those nice places in math where it all kind of makes sense logically how it works out. So in this case, we're going to end up, if you think about plugging in infinity as 5 times infinity over 3, it's going to be a type like this because x is in the numerator. And so that means our final conclusion is that as x approaches infinity, this function also approaches infinity. Now you'll notice that this is a very similar problem. In number 4, we're going to do the same steps. Drop all but the highest degree term, so we have 1 left in the numerator and denominator. And now we have the limit as x approaches infinity of 5x cubed over 3x cubed. When we simplify this, all the x terms cancel out, and so we just get our answer of 5/3. This does have a horizontal asymptote. Finally, we have here canceling out all but our highest degree terms because we're still looking at infinity. And so this limit is, as x approaches infinity, of 5x squared over 3x cubed, which simplifies to the limit as x approaches infinity of 5 over 3x. And now we have x in the denominator, so we're taking 5 divided by infinity, 5 divided by a billion. You will see that that's really, really close to 0, which is what the limit equals. Now this strategy also works with more complicated ones, but two things to watch out for. You want to make sure that if you have factors that you FOIL or multiply first. And you also want to make sure that, like in the numerator, the highest degree term might not be the first one. So when I look at this next step here, this limit as x approaches infinity, if I multiply that denominator, I get x to the 5th. And then we can multiply minus 4x to the 3rd plus 8x squared minus 7x cubed plus 28x minus 56. And then we have x to the 4th minus 5x to the 5th. And when we cancel out the highest degree term, we're going to be left with this, because x to the 5th is a higher degree than x to the 4th. And then here we're canceling out all these terms besides the x to the 5th. So we have the limit as x approaches infinity of negative 5x to the 5th over x to the 5th. Cancel out all those x terms because they have the same degree, and we're left with the limit is equal to negative 5. If you have any questions or you want to ask anything about this lesson or other lessons, please do let me know. And if you're really interested in getting printed out versions of this because you don't have a printer at home, you don't have access to a printer at all, please be in touch.